Welcome to the lecture series on reinforcement learning. In this video, we study how to induce an inductive bias into a reinforcement learning problem. And we do this using a first example. In general, before you start to encode a reinforcement learning problem, you should think about the following questions. First, is the problem such that in similar states, neighboring states, whatever that may mean, the best action is likely to be the same? Or, second question, is the problem such that if I find the reward with action A star from state S, then A star is probably good in all states? Or, do I expect rewards in many states, or rather only in a few goal states? Or maybe only there's a single ideal goal state. Finally, is there a topology, which means a neighborhood relation between actions that would allow us to talk about two actions as being similar? Now, these are difficult questions, but let's analyze these questions by way of an example. Here I have 16 different discrete states. So for example, this state here is state number 15, and I have different actions. I can move diagonally or horizontally to the right, horizontally to the left. I have 6 different actions per state. Not all of them are always possible. And now I can encode the states, its discrete states. I can encode them in a standard way by saying I have one-hot coding. If we are in state 1, then this is represented by the first unit, which is 1, and otherwise it's 0. If we are in state 2, then this would be represented by the second input. So we have one-hot coded inputs for all 16 states, but then we have 2 additional contributions to the total Q value, and these additional contributions are linear in Z, so that's something that increases as Z increases, and then I have another one, X18, which is something just like a bias. And now the question is, you walk around in this maze, you take your actions in whatever possibilities, like this, and finally you reach the goal. What will happen? Well, the Q values will change. Now the question is this encoding such that you have a certain type of generalization? And the claim is, with this coding scheme, we encode an inductive bias that's related to one of the questions. Which one is it? Well, this bias term, X18, induces the following thing. It says we have an implicit bias that relates to question 2. With this encoding, I assume that if I find the reward with action A star from state S, then A star is probably good in all states.